Hello, my name's John Evans and I'm conducting a practical research project that investigates the potential future role social media could play in the effective communication of environmental science. I'll present to you two different ways of how the same scientific message could be communicated. I'll use a policy brief as a documented conventional method of communicating scientific output, and a podcast to represent a social media. You may agree with me that firstly, there's a big gap in the goals, attitudes, perceptions and languages of scientists and environmental policymakers. Secondly, traditional methods such as scientific journals, conferences, newsletters, books, magazines and policy briefs, to name but few, have not been ideal in communicating environmental science news effectively. This poses the question, does the emergence of social media offer an opportunity to better communicate environmental science? Please listen to the podcast and read the policy brief and then fill out the survey form afterwards. Your contribution is vital to understanding how environmental issues may better be communicated. Thank you. This podcast will look at climate change and will greening cities mitigate the impact of global warming? And how effective is greening of urban areas in reducing human exposure to ground level ozone concentrations, UV exposure and the urban heat island effect? In cities, climate change may increase human exposure to high temperatures, including heat waves, ground level ozone and ultraviolet, even more than in the surrounding countryside. Could this be mitigated by increasing the greening of urban areas, increasing the abundance and cover of vegetation? This question was addressed by a systematic review of the accessible scientific referenced and grey literature. The systematic review in itself searched for primary studies that had measured temperature, ground level ozone and ultraviolet, and took into account the quality of the research and possible bias, in order to provide a rigorous, transparent, replicable and updatable review of the scientific evidence. Temperature, ground level ozone and ultraviolet were studied, and these were compared between an urban green area and non-green area. The difference in temperature, ozone and ultraviolet were measured through remote sensing, modelling and direct ground level data collection. In total, 212 relevant observational and experimental studies were obtained. No study reported measurements made before or after the creation of a green area. Most studies were thus observational rather than experimental, the exceptions being those on green roofs. Meta-analysis and narrative were used as methods of synthesis in the systematic review. Meta-analysis was used for included studies that contained enough data of the same parameter, for example means and variance, to provide quantitative synthesis. When this was not possible, a narrative synthesis was provided. These were the findings. For temperature, on average, a park was 1 degree cooler than a built-up area at 95% confidence interval. Many factors can moderate this difference, such as the park size, proportion of paved areas, wind, irrigation, season, latitude, weather and surroundings. The presence of greening elements significantly cools down the daytime ambient temperature, on average by 0.97 degrees plus or minus 0.23 at 95% confidence interval, compared to nighttime ambient temperature. The presence of greening elements significantly had a higher cooling effect on nighttime ambient temperature, on average by 1.15 degrees C plus or minus 0.29 at 95% confidence interval, compared to daytime ambient temperature. There was also some indication that nighttime cooling effect was greater in parks and tropical zones, mean difference being 1.61 degrees C plus or minus 0.6, compared to those in temperate zones, mean difference 0.7 degrees C plus or minus 0.25 at 95% confidence intervals. 3 studies report that the cooling effect is extended beyond the boundaries of park or trees. Further studies are needed to confirm this result. Urban trees have a cooling effect, but are caused mostly by shading. There is no clear evidence about which species or size of tree would be most effective, and the effect of cooling depends on the surroundings of the tree. For example, some buildings may also provide shade. No study reported a minimum amount of vegetation required to obtain the cooling effect, although negative correlation was observed between the percentage of vegetation coverage and the cooling effect. These studies were variable in terms of methodology, nature of site, and type of vegetation. Results from 6 experimental studies on the effect of green roofs on air temperature were inconclusive, but are suggestive that green roofs were cooler than non-green roofs, and the cooling effect of green area was caused by both the effect of shading and evapotranspiration. Air temperature was cooler above a green surface than a concrete surface, and measuring surface temperature showed the grass was cooler than urban surfaces, such as concrete or asphalt. The larger the green parks, the more likely it is to be cooler, and the greater the cooling effect. The difference was greater in summer, dry season, or during sunny days. For ozone, in single plants, it was found that all plants absorb ozone and emit volatile organic compounds in high quantities. The causes of the variations in the manner in which some plants absorb more ozone or emit more volatile organic compounds than others were unclear, although some studies suggested temperature, light, leaf development, stress, and plant species, for example, deciduous plants. The overall impact of green areas on ozone levels was unclear because they, in turn, are affected by traffic emission levels. Attempts to use greening to reduce ground level ozone must take into account possible counter effects due to biogenic emissions of volatile organic compounds by some tree species. For ultraviolet, trees may limit UV penetration, but the effectiveness is not directly correlated to the amount of shade measured in most studies. Penetration was influenced by the permeability of the canopy and by the variation in leaf reflectance, but this parameter was rarely measured. There are too few studies on the impact of greening on UV penetration to report any reliable conclusions. Finally, these are our recommendations. The diversity of methodologies and parameters measured across studies limits the potential for synthesis of findings. And to improve the evidence base, standardized methodologies should be encouraged, with a recording of many parameters like temperature, wind, humidity, and shade, as long time series measurements in a variety of green spaces and at different distances from them. And finally, can you tell me what impact this podcast has had on you as a viewer or listener? And do you find that the presentation of scientific information this way is easier to digest than reading the actual policy brief? Please spend only 10 minutes or at most reading the actual policy brief, and in your own opinion, compare its content with the podcast, and then fill in the questionnaire. Thank you very much.